Hi, I'm Faris, CEO and co-founder of TrustInSoft. So I met Fred like a while ago. Actually, our companies were collaborating together with some customers, and at the end, finally, we have some common investors. So we met in an event which was organized by our investors.
Hi, I'm Fred, the founder of Quarkslab, and actually before meeting at this event, because TrustInSoft was a bit in advance regarding investment, I had a call with Fabrice discussing how good and great our investors were, and so that helps me to decide to go for that investment. There are two reasons for attackers to target an application. The first one is to gain some access inside this application, either because it will allow some local privilege escalation, or to use this application to move to another piece of the network. And so it's called a lateral movement. The other reason is because the application is handling some very sensitive data. It can be intellectual property, it can be keys, it can be credit card numbers, it can be health data, whatever. And stealing this data is a source of revenue for an attacker. So whether they want to gain additional privilege or steal data, this is a motivation of attackers. And the only way for attackers to get to this data is through vulnerabilities. They can steal password, they can use vulnerabilities in human, or they can use vulnerability in applications. And both our companies are focusing on vulnerabilities in applications.
So protecting source code is very important, I would say, both at the macroscopic level and at the microscopic level. So at the macro level, what we notice is software is eating the world. So you have software everywhere. So that's definitely a big issue is if you have some hack which are possible. Things such as, for instance, Pegasus, they enable phones to be like dangerous devices because they can be hacked by people. And we noticed that initially our customers were only in the safety critical industries, and now we're shifting from those safety critical industries to, I would say, consumer electronic devices, such as game consoles or phones. So that was at the macroscopic level. At the microscopic level, we noticed that indeed there are, I would say, three benefits for which people need to secure that application. First, the first one would be for operational efficiency. That is, if you find a bug on the field, then you got to go back to the production. So that's an issue. So I would say the closest you are to the source code creation, the more efficient you are. This is the first point. Second, if you can actually market to your customer the fact that indeed you got security, your product are secure, this is a big issue. And then showing a guarantee is something about that which definitely makes sense. This is, I would say, the key business driver that we saw.
I totally agree with security becoming like now a very generic problem to everybody. A few years ago, it was really on some critical industries like defense or space, healthcare, but now it's everywhere. Computers are everywhere, so everybody has to take care of that. And as an example, when Russia invades Ukraine, we had internet connection issues here in France because they also conducted cyber operation. And actually, this morning in the news, they talk about a Russian operation on a satellite 58 minutes just before the invasion to shut down some of the communication capabilities. And these communication capabilities were not only for the military, it was for everybody, and it was very likely not used only by Ukrainian people. So it has side effects. And attacks now are not conducted only by government. They are conducted by some people wanting to have fun, but they're also mainly conducted by mafia wanting to make some revenue. So what we do when we try to protect application, whether it's to remove some vulnerabilities or prevent them to be exploited or prevent the stealing of the theft of some data or sensitive information, it's protecting everybody's life and freedom in the end, because these data are used by evil people to like ransom hospitals or shut down systems. And sometimes with these systems, it's not critical at all. Of course, it's okay if we don't have our phone for 1 hour, but it can also be very tricky. If somebody hack a car while somebody is driving this car, you can imagine the consequences. So build ship run comes from Docker. It's related to continuous delivery (CD). This is a process of continuously building, testing, configuring, deploying some new source code and application. And today's system like Azure or GCP or AWS, I don't know how many. I don't remember how many patch per minute they are putting in production, but it's just crazy numbers. And this is possible because of things like Docker now, and this continuous delivery system, which allow to build, ship, and run all the time. And that's a real revolution compared to even 5 or 10 years ago. And security in that context is very important. Of course, you want that process to be secure. That's another topic. We are focusing on building secure application, shipping them, and making sure that when they run, they are secure. So building secure application is removing some vulnerabilities, and Fabrice will talk about that. But on our end, it's also removing some vulnerabilities in parts which have not been tested automatically with proven tool. We do that manually. But it's also making sure that an attacker will waste his time or will be discouraged, that it will increase the attack cost for the attacker. What we do is we obfuscate the application. We insert some kind of traps in the application to delay the attacker and even try to notice if he's here. So we do that while the application is built. The developer develops his application normally, and while we compile the application to build the application, then we insert our protection, the different layers of protection, to prevent the attacker to read the assembly or to interact with the application. And after that, when the application is executed, it has some dynamic protection that will try to detect the use of a debugger, or that will try to detect that it's trying to communicate in a not very legitimate way with a server or with some third-party libraries or whatever. And we will try to ensure that it's actually the legitimate application. And we will send back some information, some feedback, because we also build observability in the application, which is very critical when the application is run.
Yeah, so that's definitely something super cool that you guys are doing. So you're mostly on build and run. At TrustInSoft, we're mostly on build and ship. So what we're doing is basically have a mathematical guarantee that you have no bug. It's cool, but the thing, if you do that like in a standalone manner, just at the build process, then you completely lose the fact that indeed security is a global issue. So you can't just be at one point. And something I like about the build, ship, run motto is like you should be aware of the complete software development process from the development to the deployment itself. So for us at TrustInSoft, this means being integrated, as you mentioned, with the CI, continuous integration, continuous delivery processes. And you got to be aware and completely interfaced with those processes. And this way, we're able to continuously rerun the mathematical guarantees for our customer. And this is something exactly that we were not doing in the past. Even I would say 5 to 6 years ago, we were like doing our stuff and say, okay, it's finished. We don't say it anymore. And now, okay, it's not just doing it once, but it's doing it thoroughly through the whole of the updates. Yeah.
And what is interesting is we are both focusing on the build part because that's where the foundation of security are put. It's really, really harder when you want to put security at the end of a project. We have seen that, all of us have seen that all the time. I mean, like, oh, okay, I have to deliver my project in 2 weeks. Can you secure it? Yes, but not really.
Yeah, I see what you mean. So, which tools are available? The good news is you got many tools. um, so the first thing is generally you should start by using sanitizers such as Purify, Valgrind, or UBSAN. Those definitely are the right tools. Most of them are open source, very good quality tools. Um, and you should read, I would say, the warning of your compiler as well, because they're getting better and better. So definitely that makes sense. Um, what also even you got some dynamic tools which are going to like run test campaign and help you analyze regularly all the results. This is something which is important as well. Then you got the static tools, static analyzer. This is something which is important because you will be able to grasp more things. And among these category, there's what we do at TrustInSoft, which is providing some guarantee on the absence of bugs. So it's kind of an ultimate, I would say, judge where you can say we are sure that on this kind of code, for instance, you have no buffer overflow. You don't generally do that on everything, but you do that on the critical assets that needs this level of guarantee. But we start also at the test level as well. That's basically, I would say, a kind of a panorama of the tool you might be using.
We do these kind of things manually, and that's why it's interesting when we work together because, as Fabrice mentioned, uh, the proof is available on the most critical part,
Yeah,
but attacks are like water. So if there is a rock at some place, it will go around and try to find other ways. And we are very complementary in that way because we will try to go all the other way we can imagine using, I don't know, like side channels attacks or
yeah, exactly.
fuzzing or whatever. That's different techniques. But we will try to avoid, well, okay, here we know it's a dead end. It's no need to waste time there. So as an attacker, we will test manually the other roads. But it's exactly how it goes with a different phase. You read the code, you do some static analysis, you do some dynamic testing. It's like, yeah, you test and try. To improve the security of application, what we do is we describe some kind of security properties we want to have in the application at the code level. And when the compiler does its magic, it makes the instruction that we will describe, the source code of the application together. It's like an external library, and it will bring this new security layer in the application. So for instance, if we want to detect the presence of a debugger, we will add some code to the legitimate code of the application, but it will be done at compile time, like if we use an external library, and we will say, okay, we will add some test for debugger there, and there. And we will mix different kind of tests like that, not only about debuggers and different kind of debugger. And the complexity is, the magic is really done by the compiler when we build the application. So we don't touch the original source code of the application. We add layers of protection. You all know about defense in depth. That's where we come. Obfuscating the application is helping to protect against the attacker who want to steal your data. And by data, I mean the intellectual property. If you spend years of research and development trying to create some very efficient video compression algorithm, for instance, you might not want somebody else to use your algorithm without paying royalties. Or if you are handling credit cards or handling some payments, you don't want an attacker to be able to manipulate the data so that he pays 1 or even 0, something costing 10. Or he wants to redirect the money to somebody else, or all this kind of not very legitimate application. So the goal of obfuscating application is really to protect mainly the data, and by data, it's a very wide meaning.
For a code developer, I would say that the main benefit is actually, of course, you could say it's technical because you have no buffer overflow. It's cool, but the main benefit that we are seeing for our customers is actually the communication between, I would say, the person who produces the code and the person who uses it is more fluid, because as a developer, because you have a guarantee, you can say, okay, you know what? I know the quality of the software I'm delivering. And if you're the buyer, you know exactly the quality of the code you are buying. So it makes the relationship more fluid, and you don't fight like, okay, you should do more tests, you should do more reviews, because you know that this is okay. You did the most that it was possible to do. So you can focus on the real aspect and the real question you have. So yeah, as a conclusion, I would say that what I like in the collaboration we've been having with Quarkslab, between Quarkslab and TrustInSoft, with the various customers, is the complementarities. What we are doing at TrustInSoft is super cool, of course. We love it, because we had this mathematical guarantee, but you don't do that on all the assets. So you need to have you need to have a wider vision, both to inspect that everything is fine, and to protect that the software is going to resist some other attacks that happen. And this complementarity enables to offer the full spectrum of what the customer needs, and this is why we tend to have a fairly good business together.
I totally agree with that, and I like when you prove and you give guarantee to the customer that this code is safe, and then we have to really brainstorm a lot to figure out some other attack path. But
Mm.
in the end, if or when we manage, it really increases very
Yeah,
importantly, very highly, the level of protection for the customer. And by removing the vulnerabilities before the application is publicly available, that also reduce a lot the cost of maintenance for the customer.
yeah,
And and you give guarantee for that. That's what is great with what you are doing. And then when the application is in production, with the defenses in depth coming with
yeah,
obfuscation, with the dynamic protection, with white box cryptography, with all these, I will call them tricks, that we embed into the application, it also it adds other layers of protection, making the life of attackers really much more complicated. And that's what we want to do now. The
exactly.
attackers are lazy. The attackers goes for the cheapest attack. So if we can increase significantly the cost of attacks, we will reduce the risk.
Totally makes sense. Thanks for the discussion, Fred.
Same. See you soon.
See you. Take care.